All right, so now we're going to do a little thing on rational exponents. So we talked about the rational exponent rule before, and that is if you have the nth root of a to the x, that is a to the x over n. All right, numerator, denominator. So basically when you're talking about a rational exponent or a root, as it's sometimes referred to, like the square root of 16 we said earlier was 4. All right, but there's roots other than square roots, like there's cube roots. Like the cube root of 8 is 2, because 2 times 2 times 2 is 8. Square root of 16 is 4, because 4 times 4 is 16. So, like if you did something like the fifth root of 32 is 2, because 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, is 32. All right, so to this end, if you wanted something like the fifth root of negative 32, this would be negative 2, because negative 2 to the fifth is a negative 32. That's how these roots work. And whatever you would do for a square root would also apply to a cube root or a fourth root or anything along those lines. So if we were to look at the cube root of 8x to the sixth over 125. The cube root of 8x to the sixth over 125. Just break it down cube root by cube root. The cube root of 8 is 2. The cube root of x to the sixth is x squared. The cube root of 125 is 5. 5 times 5 times 5 is 125. 2 times 2 times 2 is 8. The x to the sixth, well, if you think of the cube root of x to the sixth, that's x to the sixth over 3. 6/3 is 2. Okay. Similarly, if we were to do something like, say, the 8 times the fourth root of 3 minus the fourth root of 48. Same rules as we were working with before. You have the 8 times the fourth root of 3 minus the fourth root of, well, since you have a 3 over here, you're going to need a 3 over here. 3 times something is 48. That something is 16. Now 16, the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. So 8 times the fourth root of 3 minus 2 fourth roots of 3 gives us 6 fourth roots of 3. So all the operations, everything we were doing before, holds the same. If you wanted to do 5 divided by the cube root of 3, this is a little bit more of a challenge, because you're looking for the cube root of 3, right? Well, there is no cube root of 3, but you still need to rationalize this denominator. So if you think of your cube roots, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and the list keeps going on and on. Since we're dealing with the cube root of 3, we're going to deal with the cube root of 27. So you'd multiply 3 by 9. So we're going to multiply numerator and denominator by the cube root of 9. The cube root of 9 times the cube root of 3 will be the cube root of 27. The cube root of 27 would be 3. So our new denominator is 3. Then our numerator would be 5 cube roots of 9. There might be somebody at home going, oh my goodness, what if he puts a binomial in the denominator? We're not going to do that in this course. All right, we're just not going to do that. So that's rational exponents. Hopefully this will get a little bit better for you as we start talking about polynomials. All right. So a polynomial is a sum or difference of terms consisting of a variable raised to a non-negative integer power. The term of a polynomial consists of a variable and a coefficient, and typically an exponent as well. If the term does not have a variable, then it's referred to as a constant. So for instance, we're saying ax to the n would be a term. Ooh, let me move this down, sorry. Ax to the n would be a term. A would be the coefficient. This is your variable. There's your exponent. Okay. So we have types of polynomials, and there's really two ways to classify them. You can do it by the exponent, or you can do it by the number of terms. Okay, if you're doing it by exponent, if you just have a number a, that's a constant. If you have a coefficient and a variable, that's a linear. Then if you have a constant and an exponent of 2, this is a quadratic. If you have a constant, if you have a coefficient, a variable, and an exponent of 3, this is a cubic. Then if you have x to the 4th, that's a quartic. And then if you have anything like that, if you have ax to the n, we simply refer to it as an nth degree polynomial. Okay. Now, if you're doing it by the number of terms, if you have one term, that's a monomial. Two terms is a binomial. Three terms is a trinomial. Okay. And when we write these, we typically write them in what's called standard form, or standard form, which is descending degree. So it would be a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus blah 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 plus a sub 2 x squared plus a sub 1 x plus a sub 0. Move that over a little bit. So this here would be our lead term. And then as we go down to the end, this would be a constant term. So that's how we classify our types of polynomials. With the operations of polynomials, we're going to talk about addition, subtraction, and multiplication. All right, division of polynomials is a whole other can of worms to talk about another day. And really, addition and subtraction are the same thing. Okay, and when you're adding and subtracting, polynomials, it's all about combining like terms. Combining like terms. So if you had something like 2x to the 4th plus 6x to the 4th, these are like terms, 8x to the 4th. However, if you have if you have 2x to the 4th plus 6x squared, since this is an x to the 4th and that's an x squared, these are not like terms. Sadly, they cannot be combined, and they're stuck living a life of solitude forever. So, that being said, if we have 2x cubed plus 5x squared minus x minus 1, and to this we wish to add 2x squared minus 3x minus 4, we would combine our like terms. Does 2x cubed have anybody to play with? No. 2x cubed. Done. 2x to the 5th, I'm sorry, x 5x squared, 2x squared, these are both x squareds, add those together, 7x squared. Negative x and a negative x, so these guys are done. A negative x plus a negative 3x gives us a negative 4x, and then a negative 1 plus a negative 4 gives us a negative 5. And that's that one. And then if you're subtracting, negative 7x cubed minus 7x squared plus 6x minus 2 minus 4x cubed minus 6x squared minus x plus 7. So if we're subtracting, what we're going to do here is that we're going to take this negative sign and distribute it to everybody that comes after. So this new polynomial, negative 4x cubed plus 6x squared plus x minus 7, all those take on their negative sign, their negation. So combining these, we get negative 11x to the third minus x squared plus 7x minus 9. So that is our addition subtraction. To bring us to the idea of multiplication, when you're multiplying terms, when you're multiplying terms, it's multiply the coefficients, add the exponents. So if you have 2x to the 7th times 3x to the 3rd, 6x to the 10th. Multiply the coefficients, 2 times 3 is 6, add your exponents, 7 plus 3 is 10. Now if we take this to another level, 2x minus 1 times 3x plus 4, the binomial, maybe remember the good old acronym of FOIL. First, outer, inner, last, you're going to do double distribution. 6x squared plus 8x minus 3x minus 4. The firsts, the outers, the inners, the lasts. Six x squared plus 5x minus 4. Now if you wanted to beef it up a little bit more, 3x squared minus x plus 4 times 2x plus 1. Now here I don't like to do that whole double distribution or FOIL method, because here you've got first outers, inners, and then you've got middles and all this other crazy stuff. I like to rewrite this as 3x squared minus x plus 4. Then I write the 2x plus 1 underneath. And I basically multiply it the way you would a 3-digit and 2-digit number, because in theory it's the same thing. I'm going to start off with my 1. I'm going to multiply 1 by each of these terms. So 1 times 4, 1 times negative x, 1 times 3x squared. Since it's the multiplicative identity, comes out like that. Now the 1 is done. Now I'm going to multiply through by the 2. So 2x times 4 is a positive 8x. I'm going to write my positive 8x underneath there. 2x times a negative x is a negative 2x squared. That's going to go under there, under my x squared terms. And then 2x times 3x squared is going to give us 6x to the third. Now, I'm going to add these together. And everybody's lined up in their little columns. 6x cubed plus x squared plus 5x plus 4. So that's a neat little way to multiply through and just keeping it more organized. I like this way for organization purposes. You can really do it a whole bunch of different ways, and whatever works for you works. So the last thing we're going to do is factoring. And we're going to talk a lot more about factoring through this course. So really all I'm looking to do here is just to wet the palate, so to say, and try to, bring up some memories, because we're going to do it more when we talk about functions and polynomials and things like that. So these are the four major ways of factoring. You have GCF, which can always be used, all right? Not always, but pretty much it's your first one. It doesn't matter if you're dealing with a binomial, trinomial, 4 terms, 5 terms, whatever it is. I found that looking at these by looking at the number of terms tells you how to factor it. Just always try a GCF first and hope it works. The dot sum and difference of 2 cubes, this is used when you have 2 terms. The reverse FOIL, trinomial, QT, there's all different names for it. 3 terms. I refer to it as a guess and check. Grouping is when you have 4 terms. So just to take you through these each and show you what I'm talking about. So for a GCF, all right, we're looking at something like 6x cubed y cubed plus 45x squared y squared plus 21xy. You're going to look to see what all 3 of these have in common for their factors. So if you look at 6, 45, and 21, the number that goes into 6, 45, and 21, the only number that jumps out at me is 3. All right? Because 3 times 2 is 6, 3 times 15 is 45, 3 times 7 is 21. So 3 comes out of all 3 of those. And then since 2 and 7 are prime numbers, I know there's nothing bigger that can come out. Now we're going to look at our x's and look at our y's. So we have an x cubed, y cubed, x squared, y squared, and xy. The best we can hope for is an xy to factor out, because we can take 1 away from here, that'll leave us with none. We have 2, we have 3, we can't take 3 away from over here, because then we would end up with a deficit. So now we just have to figure out what goes on the inside. 2x squared, y squared, plus 15xy, plus 7. So that's one way to look at GCF. Another way would be 3 times 2x plus 1 plus y times 2x plus 1. What's inside of these parentheses can be treated as an entity. So it's no different than 3a plus ya, and we can factor the a out. So we're going to factor out the 2x plus 1. And then we have 2x plus 1 times 3 plus y. So whatever's inside parentheses, so long as they're the same, you can factor them out just like you would anything else. The second method, when you have 2 terms, you have dots. And dots is nice because it has a nice formula to it. A squared minus b squared is a plus b times a minus b. So something like x squared minus 81 would be x plus 9, x minus 9. Or x to the 4th minus 16 would be x squared plus 4, x squared minus 4, but x squared minus 4 can be factored further. to x plus 2, x minus 2. You can't factor x squared plus 4 at this point. Okay, there's no SOTs, there's no sum of two squares. Okay. In the difference to the difference of two squares, we also have the sum and difference of cubes. Sum and difference of cubes has two formulas. You have a cubed plus b cubed, which would give us a plus b, a squared minus ab plus b squared. Or a cubed minus b cubed, a minus b, a cubed plus ab plus b squared, sorry, 2's, like that. So just as an example, a to the third minus 8 would be a minus 2 times a squared minus plus 2a plus 4. Okay. Or x to the third plus 27 would be x to the third plus 27 would be x plus 3 x squared minus 3x plus 9. All right. Our last two methods, trinomial. For the trinomial, I basically use guess and check. And I'm kind of, like, I know that there's all these other ways of going about doing it, and I just find, you know, guess and check is really the most straightforward way to go about it. People get hurt less often doing it with guess and check. So if you have something like x squared minus x minus 12, this is a trinomial, you have three terms. So since it's a trinomial with three terms, you know it's going to factor to two binomials. What multiplies to give us x squared? X and x will multiply to give us x squared. What multiplies to give us 12? Well, you've got factors of 12. You've got 2 and 6, 3 and 4, 1 and 12. These are all the factors of 12, but we need a negative 12, right? So if you start making some of these negative, plus 3 minus 4, these will multiply to give us a negative 12, but then when you add them together, you get that negative x in the middle that you need. This is the guess and check method. Your textbook does go through a different way of doing this, and you're welcome to read about it and to explore it. I personally don't particularly care for it. I've just always been a guess and check guy. I'll do another one for you. So another one would be like 2x squared plus 9x minus 18. 2x and x are going to multiply to give us 2x squared. Now we've got to look for factors of negative 18, but this one's going to require that whole guessing and checking because we need to add to a middle term of positive 9. So I'm going to throw in negative 3 and a positive 6. Now you're looking at this saying, oh, well, those don't really add to 9 because negative 3 and a positive 6 add to a positive 3. We need a negative 9. But look at what happens. If you do your outers, you get 12x. You do your inners, you get negative 3x. Add negative 12x and 3x together, you get your positive 9x. That's our middle term, and everything works out for us in the end. It's kind of nice. So you might plug in different numbers and keep working, but the idea is that you plug numbers in, you guess, and then you check to see if your answer is right. The last method, method 4, called grouping, is when you have four terms. And what you do is you group the first two together group the second two together, and you're going to look for their GCF separately. 5x cubed minus 3x squared has a GCF of x squared. 5x minus 3. 10x and 6x has a GCF of a positive 2. Now, if you've done your factoring by grouping correctly, these should be the same. You should have 5x plus 3 or whatever it is. Whatever these are should be the same, because now that these are the same, it becomes like this example up here. So you factor out the 5x minus 3's and you get x plus 2 together. Okay? We're going to talk a lot more about factoring. So I do want you to practice this and explore it a little bit more, but just know in the end that we're going to keep doing more of this factoring stuff as we go on. All right? So we kind of did a lot here in this first module. So we talked about number systems, the property of real numbers, our exponent rules, order of operation, radicals, rational exponents, polynomials, and factoring. One thing I didn't cover in this module, however, it will be a part of your homework, is the solving equations, but they're first degree equations. So I just want you to look at those and give yourself a little bit of practice. So I don't mean to scare anybody or put anybody off. I know I went through this module kind of quickly. It's the prerequisite stuff that you're supposed to know from your other math courses or based upon your placement test. After this, you'll see that the pace will slow down a little bit as far as my notes and everything else. So if you have any questions, I cannot emphasize enough, please email me. I'm very much available through email, so just send me an email and I'm usually back to you within 24 hours. All right, so I am available. I am willing and ready to help if you need anything. So, all right, welcome to the class and thank you.